This video is to go over how to find the roots of the equation. So the problem is find the roots of the equation x to the 11th minus 1 equals 0. So we should have 11 roots or the numbers that satisfies this equation. So first we're gonna let x be RCIS theta. So this is the general form of polar form of a complex number. And we also let 1 to be 1 CIS 0. Because 1 is, if you think about the polar coordinates, how do you get to 1, 0? You just don't change the direction or the argument. You don't turn your body, but you just take one step to the real axis. Only one step. So 1 can be written as 1 CIS 0 as a polar form of it. Now substituting these will give us x to the 11th power, which is this one now. So RCIS theta to the 11th power minus 1, which is 1 CIS 0, which equals 0. Or just simply you are subtracting or adding 1 CIS 0 to both sides and getting RCIS theta to the 11th power equals 1 CIS to the 0 power. By multiplication law, this RCIS theta will be R to the 11th power and CIS 11 theta. Now left side and right sides are equal, so this guy R to the 11th power must be equal to this guy 1, and this 11th theta should be equal to 0. Now, since this is a periodic function, 11th theta could be 0 plus 2 pi times any integer k. So if we work on this part, R will be equal to 1, and then this 11th theta could be dividing 11 to both sides, theta will be 2 pi k 11. So we'll have R, which is 1, So we're just going to substitute it to this guy, which is RCIS theta. R is 1, and theta equals 2 pi k over 11. Then if you substitute in k, so we have 11, so imagine that we have a unit circle, and then we have 11 dots equally distributed. So we'll have CIS 2 pi times 0 over 11th, which is going to be just simply 1. 2 pi times 1, which is CIS 2 pi over 11th. 2 pi times 2, which is going to give us 4. 2 pi times 4. 2 pi times 5. 2 pi times 6. 2 pi times 7. 2 pi times 8. 2 pi times 9. And then 2 pi times 10. If you do 2 pi times 11, that's going to be 22 pi over 11, which is going to be, just write it, not 1 right here. It's going to be 22 pi over 11, which is going to be 2 pi, which is going to be the same as 0, which is going to be the same as this 1. So it's going to continue going around the circle. So we'll stop here. So these are the 11 solutions. Make sure to have it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, we only have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We should have 11. Oh, we didn't have this 4. We forgot to have 4. There you go. That's 11 more. So that's the 11 solutions, and likewise, as we said at the beginning, we should have 11 solutions for this because we have 11th power.